Hello, and welcome to the Edge MEC Solutions session. I'm Brandon Weilbacher. I'm the Senior Director at Flex. You know, as we face this COVID-19 pandemic, the health of our families and coworkers and loved ones is obviously mine and everyone's first priority, so I hope everyone is staying safe. You know, this virtual conference is an example of how we've really altered the way we interact with each other. You know, most of us are exclusively working and studying and homeschooling and teaching from home now. And so the technology that makes that happen and enables this new lifestyle, you know, they're viable largely due to the evolution of 4G and 5G and data center communications technologies. And, you know, all of this team, this OCP group and the ecosystem has a big hand in building. So thank you for that. So today I'm going to be talking about some of the challenges we're seeing at the edge with a specific focus on how we can optimize our solutions, you know, what are some of the deployment challenges, and also address some of the lifecycle management. Okay, so before I get into that, I think it's worthwhile to give you a little bit of perspective on where I'm coming from. So I'm from Flex, and this is kind of how Flex views these three categories. So when it comes to optimization, we design customized systems to meet our customers' requirements. So that's kind of what we see as the main point there on optimization, is the customization aspect of it. For deployment, you know, Flex is one of the largest manufacturers in the world. We have the scale and can have the large volume for manufacturing and system integration and rack integration. So we see a lot of that. I'll give you some of the perspective on that I'm seeing from our customers. We also have a strong supply chain, which enables all this to happen. And of course, a global footprint, which not only gives you a lot of capacity around the world, it also gives you a local view and a regional presence to help with that deployment. Okay, and then finally on lifecycle management, I see this, you know, from the perspective of repair, warranty return, and really the whole circular economy. Okay, so to demonstrate and talk about some of these challenges, I wanted to go through a case study. I thought this would be the best way to show a real world example. So this is, you see the unit here, it's a roadside unit. It's an edge compute node which supports autonomous driving and V2X use cases for smart cities. And this edge compute function provides a real low latency communication, which is in close proximity to the vehicles it's serving. And so this gives you kind of close to a near real-time experience. But the network architecture, keep this in mind, it requires installation of numerous systems, you know, along the roadside. So in this case, we're a good partnership with this customer because we had the capacity to mass produce these units. Okay, now when you start thinking about this unit, you know, unlike most server hardware that sits comfortably in an environmentally controlled data center, this edge computing node has to withstand and be protected from all the outdoor elements because it's typically located outdoors. So that includes, you know, rain, lightning, dust, temperature, humidity, and it also needs to be physically secure from vandalism. And another physical aspect of it is that it needs to be fairly light. It cannot be too heavy because it would make it too hard to install, and it would make it impossible to install in some of the locations where they want to put it. Okay, and then we talked about the volume. You know, when you think of edge computing, you're distributing the data center down closer to the users of the data, and often that'll mean a whole bunch of servers in a lot of different places. So there was a large volume required. Okay, so those are some of the challenges and requirements we saw on this project. In the end, this was a very successful partnership. We were able to work with this customer to deliver a proof of concept system in a month, an EVT system, you know, the early engineering validated tested system in 4 months. And today it's now ramping into production. So this was a good example of an edge use case and case study. Okay, so to cap off this brief introduction here to our panel, let's go over some of these conclusions and some of the challenges that we saw in this project and just what we see in general from Flex's perspective. There's often a need for highly customized solutions. Most of the customers we work with are not necessarily buying units right off the shelf that are ready to go. They all typically require some sort of customization to meet their specific requirements. We're also finding that our experience designing in all these multiple industries is helpful because every industry has its own unique requirements. So in this case we just talked about, it was very helpful to have experience designing for the automotive industry, for the telecom industry, and of course, cloud data center technology. So that was a good match. Environmental challenges, not just in this case where the unit has to be outdoors, but in other cases, when you're deploying edge nodes, they may not be in a typical data center. You know, they may be in a basement, or they may be in a cabinet or a micro data center in a container outdoors. In any of those cases, it's not the typical environment, whether it's temperature, humidity, or it's even just the space available and the amount of space that you have to deploy the unit. So having a strong mechanical team that can work around all of those thermal requirements and physical requirements and design the custom solution is a consideration. Okay, we talked about this a little bit. I'll mention it one more time, is that, you know, with the number of units required in edge deployments, you're often going to be looking for partners that have the ability to mass produce and do system integration on a very high volume level. Okay, finally, we didn't talk about this too much, but this is another consideration that we're seeing, is that some of our customers are looking for partners that can provide the full circular economy. So after the unit's been deployed, you know, can the provider repair the unit? Can we do warranty servicing? Can we then recycle them when needed? And so this circular economy is becoming more and more important. Okay, so hopefully this gave you a good brief introduction to start our panel and to get a good discussion going. It gives you a view of how Flex sees things and what we're seeing out there in the market from our customers. So thank you for attending this session, and please stay healthy and remain heads down, driving progress within this technology ecosystem. Thank you.
Hello, my name is Elad Blad. I'm the CSO for Silicom, and I'll be presenting Whitebox MEC Solutions and Tools. When we look at the mobile edge compute, the MEC, the moving parts inside are the radio heads, frontal gateway or a gateway, DU, distribution unit, centralized unit, and other pieces as well. You can see the diagram contributed by AT&T in 2019. Showing off 4G and a 5G deployment, CPRI and eCPRI, and how they are converted to banks of DUs or BBUs. The solutions that assemble the above share the same building blocks. You will find in most of them a switch, a CPU, some ASICs, an FPGA, time sync mechanism, and a BMC. And that will comprise each and every one of them to a certain extent. What Silicom is claiming, and what we would like to see done at OCP, is the Lego approach, meaning it should all fit, it should all work together. So you've got your CPU, switch, BMC, FPGA, as we discussed in the previous slide, all open, meaning all of them are programmable, all of them have some reference designs, all of them have some reference code. So Silicom will be providing a reference designs for most of these, and we'll go into details. So first of all, Intel CPU boards, some already contributed, others of new generations coming and will be contributed later this year and in early 2021. Silicom is working very closely with Intel to implement those, and will contribute every single design that we have done on the new designs. On the switchboard, we have contributed a few, namely Marvell and Broadcom, and we plan to do more. More are coming, Intel-based and others. And again, the API in this case will be contributed via an NDA with the ASIC vendor. So you need an NDA with the appropriate ASIC vendor, but the framework and the actual hardware design will be contributed by Silicom. Some already contributed. On the secure BMC front, for edge deployments, we've got a micro BMC. It's already a launch tool, and we're in the process of contributing it. The merits of that tool is secure remote connection. All of the secure remote connections are IPsec tunnel based and fully secure, as well as an integral BMC like your typical Redfish and alike towards the inside of the system. Now, the FPGAs are a tricky part because FPGAs are fully programmable, as you know. So on that front, we offer both the actual hardware design of the board as well as a high-level code, meaning like a shell for time sync, for 5G, CPU-to-CPU mapping, compression, splits, etc. And we do this for both FPGA vendors, big FPGA vendors. So we're hoping that by giving you both the hardware design, reference designs and tools, and the software code, more clients and more users will be able to take that and build some of their own. So to complete that picture, you've got to have the orchestration software and the management software, and that will come from partners such as IP Infusion, who are the owners of Danos, ecosystem partners such as Telco Systems, RAD, Adva, Equinox. So your run-of-the-mill router guys will be providing the software for these type of deployments. And the way we see it, the more software vendors come and join us, and we invite them all to come and join us and offer code for managing frontal gateway, for managing a DU or CAS. More hardware vendors select pieces and build something out of those pieces. If it would be, again, the CAS or the DU or CU, enabling them to choose their pieces and to be agnostic about the choice would be to great benefit, and we're asking them to do so. Contributions are expected to be done during 2020, including micro BMC, an FPGA, a few designs, and then a few more, and switchboards. The rest are already available. And again, as soon as more technology is released to the market, we will release more reference designs. And a possible schedule for full product is Q4 of this year, where Q3 probably for samples. And we're now looking for more and more partners to join us to make this a reality, because we believe that 5G should be as open as CPEs are at this point in time. So thank you.
Okay, thanks for joining the session. This is Brandon Weilbacher from Flex. I think we would now be open to Q&A. So I'm monitoring the chat window here to see if any questions are coming in.
There's a tab for Q&A, actually.
Okay. There it is. All right, we have a question from Jack. He says, Elad, do you have a link to the FPGA hardware designs?
So I think that, first of all, you can find a large selection of them on our website, and we'll be releasing a few more in the coming months. You can expect to see the latest Intel chipsets on those FPGA cards, and the hardware designs are actually PCIe add-on cards or modules. So that's what you can expect to see in that front. And as far as the actual code, please talk to us and we can go into further detail.
Very good. All right, looks like Dan Pitt has a question. He says, what happened to the two panelists from Nokia? I don't know if the Nokia gentlemen were able to join the call. Are you on the call now? Okay, so obviously they weren't available.
Okay, Elad, we've got another one for you here. Is the micro BMC contribution hardware, firmware, or both? And then is the firmware based on existing framework, or is it completely new?
Okay, so it's based on an ARM CPU. First generation was TI, and now it's Marvell Armada 3720. So you can definitely get the hardware. The software is based on open source, so we can actually give it to you. We did our own stack, but it's based on open source software. And there's actually a community called microbmc.org that you can join.
Okay, not too many more questions coming in. I was just going to mention that Elad's company, Silicom and Flex, work together and partner on projects. So just wanted to kind of emphasize the value of the whole ecosystem here, where Flex can often be the manufacturing and the fulfillment and system integration end, where Silicom is coming in with a lot of these unique technologies. So Elad, I don't know if you wanted to comment on that at all.
Sure. I think the idea that the tools that we're bringing are just that, tools. We look for partners such as Flex, and Flex is a great partner for us to actually build those tools and make them into a deployable product in the thousands or in tens of thousands. So it's definitely something that we actively go after with a partner such as Flex.
All right, very good. Okay, look, few more questions came in from Jack. He says, what is the target temperature for the CPUs? Must be hot in those metal boxes. I think that one's for you, Elad.
So it depends on the type of deployment that you have. Of course, you have your standard deployments that are in the office, and those are standard office temperatures for the x86. So your typical box will be between 040 to plus 65. And if you go after the external or the ruggedized IP67 or IP65, you've got a much heavier enclosure that allows the components that are chosen that are also extended temp to go beyond that, more to the area of above 100, and the heat and minus 40 is still the low point. So it really depends on which CPU and to what type of deployment, but the box and the component selection is tailor-made for that type of mindset, meaning to fit the use case.
Makes sense. Okay, Dan Pitt had a question, I think, for me. He says, you only show the RSU. What about the cell tower, the building edge, and telco CO? Good question. So, of course, yes, I just showed one case study there where we worked on that RSU to try to demonstrate that Flex often operates in this, well, what our customers kind of think of us as a global system integrator of choice for them. And so we'll put together the pieces and test them, and often develop some of the missing pieces, whether it's around the chassis or the thermals or any special add-on cards or what it can be whatever is missing in the total solution. And we do that, of course, in this example for an RSU, but very much in the other locations you mentioned as well. So for pole-mounted DUs, that's something we work on. Building edge servers, telco CO servers with NEBS compliance. All of those requirements and all of those different locations are definitely projects we work on with our customers. Thanks, Dan. That was a good question. Okay, are there any other questions? I don't see any more coming in. Okay, Elad, any closing comments?
Just that we are very focused on 5G and these type of deployments. And as I said, we are viewing the offering that we're building together with Flex and other partners such as Intel to cover all the way from the RU, which is brought by the RU vendors. So frontal gateway, DU, BBU, and CU are all pieces that we're going to build together, and we're already building together towards that complete ORAN or OCP-driven ecosystem. And I hope that we can get more partners to join us.
Okay, very good. Okay, well, my closing comments are for everybody to stay safe and healthy, and I look forward to seeing everyone face-to-face the next time we do this. So since there are no more questions, I think that concludes our panel a few minutes early. Thanks, everybody.
Thank you, Brandon.